going to talk about isomerism. So let's say you have iso and merism. We have two words over here. Iso means same, merism means parts. So let's understand this concept with the help of an example, an analogy. So you have these Legos and you can make different shapes out of the same Legos. Let's say you have like these 10, 11 Legos, and you can make like plenty of shapes with it. You can arrange them in different ways to make different types of structures, different types of things. You can make a car, you can make a building, you can make anything out of them. So, but their building blocks, they are the same. So this is exactly what isomerism is. So you will have compounds. These compounds, they will have the same components, but they will maybe look different, or maybe they have different structures, or maybe they are arranged differently. It's it is just what isomerism is. So let's take an example. So you know that organic compounds, they show isomerism. So let's take an organic compound which has like around four carbon atoms, and you will have each carbon atom needs three bonds. So CH3, this will become CH2, CH2, and CH3. So you can see that this is a molecule. Let's just forget the names for a bit. Now you can see that they're arranged in this straight line. Now another way we can arrange it is just take three carbon atoms like this and add a branch carbon to it, and then you can say like CH3, CH, because it already has three bonds, and then this one needs three more, CH3 and CH3. Now your task is to calculate the number of carbons and hydrogen in each of these molecules. So it has like four carbons and it has like 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 hydrogen atoms. And this one, it also has like four carbons. And when we look at the hydrogen, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has the same number of hydrogens as the one, but they look different. But they have the same molecular formula. So what does it mean? They are isomers of each other. Right. So when this is in a straight chain, we call this N-butane, and this is in the form of branches, like the branches of a tree. So we call them iso, and this molecule is called butane. So we call it isobutane. So there is what we see. They have the same molecular formula, but they have the different structural formula. Now, there's another thing which can occur when they might have the same structural formula as well as the same molecular formula, but still they're different. They're still isomers. So just look at these benches. So I just have inverted this image. Um, you have carbon atom and you have carbon atom. So over here you can say like we can have a double bond over here. Just think of this double bond as these benches. So they're like having this like double bond, and there's carbon on this side and there is carbon on this side. Now let's think of this molecule, and you can have a hydrogen over here and the hydrogen over here and a CH3 over here and CH2 over here. Now you can see that you have a hydrogen on this side and the hydrogen on this side. They are the same compounds or identical compounds. It's just like having a hydrogen sitting on this bench and the hydrogen sitting on this bench. and a CH3 sitting on one side of the bench and a CH3 sitting on the other side. Now you can see that you just think that you and your friend are sitting on the bench like side by side. So you are like this. But what if I say that, okay, I just don't want you to sit together. You one of you can sit over here and one of you can here. So I'm like, no, you cannot sit like this. Just take, can I just place you over here and just place you over there? Like seriously, just sit over here. And hydrogen, like you can sit over here. So like they are the same thing, but they're just sitting a bit differently. So over here we can say like, yeah, you are the same thing, but you have a hydrogen over here. Your hydrogen just come over here or this side and just yes, you just go with this side. Like, yeah, you're arranged the same way, but just go with it. So you get this. Now, you haven't changed the structure, you haven't changed the number of atoms or anything. You have just changed their seating arrangement. Like this hydrogen, like they are sitting on the opposite sides. So these two molecules, they have the same structural, same um, molecular formula, but they have different arrangements. This is called spatial arrangement. So this is what another type of isomerism is, and this arrangement in which they are sitting like on the same bench, as you can say, this is called cis form. And this one means they are like sitting like opposite benches. This is called transform. Right. So this was another type of isomerism. But there's another thing, a way in which you don't have necessarily have different spatial arrangements, but there's a different concept. So think of a mirror. So you place your hand in front of the mirror, and you can see a reflection of your hand, or just take your two hands. Just look at your left hand and your right hand. So they are mirror images of each other. But if you place one hand and place another hand on top of it, they don't really align. So basically, they are the same mirror images, but they are different. They have a different orientation. Just look at this arrow, and this is the mirror image of that same arrow. If I want to place this arrow and this arrow, like they are not the same. Like they're identical. They're almost identical, but they are not the same. This is something we call as optical isomerism, and we can discuss this in detail later. So now these are some like the three types of isomers which I have discussed. Now let's look at. All right, so you have these are the types of isomerism. So you have the structural isomerism in which you have different structural formulas, just as you saw over here. This is like N-butane and this is isobutane. And this is stereoisomerism, which we had discussed using the examples of these benches and this mirror. Now, let's talk a bit in detail on the types of structural isomerism and yeah. So you can see chain isomerism. It isomers the molecules, they are different just because they have different chain lengths. Or you can say that over here we had this was a straight chain molecule, but this was a branched chain molecule, so there is a difference in the length. So this is why this is a chain example of a chain isomerism. These are called chain isomers. Now the next one is position isomerism. So in this isomerism, you will have the same function group, but its position will be different. For example, you have one, two, three, four, and five carbons over here. Now this, we can place a double bond or here, or we can place a double bond one, two, three, four, five in the center. If one, it would be the same molecule, but the functional group is placed on different places, so they are position isomers to each other. Just like that, around, you can have like an ether functional group, and you can have carbon, carbon, and carbon, and like carbon like this. Or you can have it in the center like this. So the functional group is the same, the number of carbons is the same, just the functional group it has a different position. It's just that. This is what position isomerism is. Now let's see what functional isomerism is. Same number of atoms, same num the molecular formula is the same, but the functional group is different. For example, you have um, ethers, and you have alcohols. So let's take an example. You have an ether, you have an oxygen, you have a CH2, CH3, and this. So this is a compound of ether. And you have alcohol, let's say you have OH. We have three carbon atoms, one, two, and three. So CH3, CH2, and H2. Right. So let's just separate. Right. So this is an ether, compound of ether, and this is an alcohol. So you can see that one, two, three, you have three carbon atoms, and you have three, four, five, six, seven, eight hydrogen atoms, and you have one oxygen atom. And over here you have like one, two, three carbon atoms, one, two, three, four, five, six, seven, eight hydrogen atoms, and you have like one oxygen. So yeah, so we have the same molecular formula. It's just that they have different structures. Why? Because they have different functional groups, right? Just like ethers and alcohols, we have aldehydes and ketones. They also show isomerism and so on. Um, Now let's move on to metamerism. So in metamerism, two compounds, they are the isomers to each other just because they have a different number of carbon atoms on each side of the functional group. Let's take an example of the simple ether. So you have like an oxygen, and you can have as many carbon chains as you want. Let's say you have an oxygen and you have like one and two on this side, and they have like one carbon. You can just balance it, and you have one carbon and one carbon. They are the same molecules. Not the same, they are the identical molecules, but they have different carbon atoms on each side. So there's this not same distribution of carbon atoms. That's why they are called um, isomers of each other because of this phenomenon known as metamerism. Now let's talk about tautomerism. So in tautomerism, there is a transfer of a proton within the same molecule, due to which the molecules they become looks like different, but they are the same. They are isomers. So let's take an example of amino acids. So you have carbon, you have a hydrogen, you have this R chain over this side, and you have COOH, proton, and you have the NH2 bond over here. Now, what can happen is that this hydrogen over here, it can just come with this nitrogen over here, and it can form NH3 over here. So what would happen is that C carbon, hydrogen, R. So this, it can lose this proton to get a negative charge. And if we become, if we gain an hydrogen and we become NH3 positive, what's the difference? They have the same atoms, they have the same everything, but just the thing is that there is a transfer. That's that's what has happened over here. So this phenomenon is known as tautomerism. They are both isomers to each other, and yeah, that's the thing. Then we have the ring chain isomerism. It's just like as if you have a, a ring-shaped compound, like a closed-shaped compound, let's say carbon, and you have another carbon. I have four carbons that are like closed in a closed chain, and this will have CH2, CH2 over here, CH2, and the CH2. Now, how many carbons do you have? Four. So just place them one, two, three, and four. Now, how many hydrogens do you have? One, two, three, four, five, six, seven, eight. So just like place three over here, three hydrogen here. So six, we have two left. So H and H. And we can balance it by this one. So this carbon one, two, three, four, balanced one, carbon one, two, three, four, balanced. You can see these are two molecules. They have the different structural arrangement and they have a chained isomer. So type of this type of difference that they have the same molecular formula, but they have different structural formula such that one of them is a ring-chained compound. This is known as ring-chained isomerism. Now let's get to the other branch of isomerism. This is called stereoisomerism. We have two types, geometric isomerism and optical isomerism. Geometric isomerism is the name for this thing. So you have different spatial arrangements, different geometry, but the concept is the same. So these benches, this this what you have studied over here is what geometrical isomerism was, and you have two types of geometric isomerism. You have a cis chain compound, and you have a trans form, and yeah. And then you have optical isomerism. Yeah, we have touched it upon it a bit. So what actually is optical isomerism? So in optical isomerism, you just take a compound and you pass a polarized light through it, and it will just move the light in a direction. It can be either the clockwise direction or the anti-clockwise direction. So these two were the mirror images. Can happen that this one moves the light in the clockwise direction, but this one moves the light in the anti-clockwise direction. So these two compounds, they will have some similar physical properties, some different physical properties, some similar chemical properties, some different chemical properties. It's just that they are somewhat similar but somewhat different. So they're mirror images to each other. That is what isomerism is. Isomerism is an amazing phenomena. It occurs. It has. It is because some molecules can have millions and billions of compounds. Even the more carbons you have, the more bigger the molecules are, the more isomers they will have. So it's such an amazing concept and we all should just look at it that how these different compounds they are formed and how does this nature it has all these different kinds of um phenomena happening into it. Thank you for listening. See you next time.